Hi, guys. So today we're going to talk about how you can see the difference between physical and chemical changes at a molecular level. Now, obviously, we cannot, with our eyes, see molecules. So, the ways that we've been talking about physical and chemical changes so far, we're using things that we could see. So, for physical changes, if you rip something or break it, or if you change its phase of matter, those we said were all physical changes. And for chemical changes, we said that you were forming some kind of a new substance. So you might see bubbles, you might see a solid, you might see a color change. But really, what's happening on the molecular level is that for physical changes, you're going to notice that the molecules are different than what happens with chemical changes. So we are going to look at that today. So for right now, this first slide of this whiteboard is physical changes. And I have made a little diagram for you guys of the molecules in phase changes. So these are water molecules that I made, but they could really be any type of molecule, but I modeled them after water. And so when they're in a solid, like right here, they are tightly packed together. And then as they go from a solid to a liquid, you can see that they start to spread out a little bit more. And then as they go from a liquid to a gas, they spread out even further. But notice in each of these phases, the molecules themselves are not changing. There's the same amount of them, and they still look the same. They are made of the same thing, and the substance that they're made out of is not changing. And notice I added these arrows, which we've talked about in the past before, which go back and forth, which means that I can go back and forth between the phases. So I could go from a gas back to a liquid. I could go from a gas directly to a solid. I could go from a solid to a gas. There's all those different possible phase changes. And you can always change it back, which is a really important thing because in a chemical change, once you complete a reaction, you can't necessarily turn your new substance back into what it originally was. So for phase changes, you can always make those molecules go back into one of the other phases under the right conditions. Now, let's talk about what the molecules would look like for some other physical changes. So we talked about bending. So let's say I had some, I don't know, this could be like a sheet of metal, maybe. And I have all my molecules in there. Then if you bend it, the molecules in there are still the same. So notice there's still my same green dots. They're still the same distance apart. All I've done is bend whatever my piece of metal that I drew here. Same thing for if we broke something. So if we had plastic and then you broke it in half. Ignore the fact that these are the wrong sizes. I am not a great artist. But notice, again, even if you broke it, the molecules are still in the same place. It's still made out of the same material. And lastly, same thing for ripping. So if we had like a piece of paper and then we ripped the paper, even if you rip it, it's still made out of paper and all the paper molecules. So in that piece of paper, there's probably, millions of little atoms. Well, they still are exactly the same in the paper once you rip it. Now, the difference for chemical changes is that you have reactants and then you have products. So on this diagram that I have made, we have our reactants, which is a blue circle and two green squares as one molecule, and then two yellow triangles as my second molecule. And when I combine them, they chemically react to form two new molecules, one with a blue circle and two triangles, and then one that is just two green squares. So an example of this reaction that we've talked about in class could be if I had something like barium chloride reacting with fluorine gas, and that would make barium fluoride plus chlorine gas. So notice in this example, we could use chemicals, but we can also use shapes to represent our chemical changes. And we end up with different molecules than we started out with. And that is one of the key things for a chemical change. In order for it to be a chemical change, you have to be turning your reactant into something else that is entirely different. So another example that we've talked about with this is burning, and that's our most common example. So if I were to like burn a piece of paper and I can't undo that. So this is an example of a combustion reaction. So remember we said they're also called combustion. But notice how everything on the reactant side, you do not see that again on the product side. You do see the same elements, but they're rearranged and they're in completely new and different molecules. So one thing that I really want you guys to think about is, what is the difference between the molecules in a physical change and the molecules in a chemical change? So what is the difference between the molecules in a physical change and the molecules in a chemical change? So in a physical change, the molecules stay the same. And in a chemical change, the molecules change into new molecules. So hopefully seeing all these molecules helps, and you guys are going to use these examples in the follow-up activity where you are going to be classifying different images of molecules as either physical or chemical changes.